Hello and welcome to another Portworx demo. My name is Bhavin Shah, and in this demonstration we are going to talk about how you can leverage AWS Karpenter to scale your compute and memory capacity in your Amazon EKS clusters and leverage Portworx Autopilot at the same time to scale or automatically scale your storage backend for your stateful applications running on Amazon EKS. AWS Karpenter is an open source project that will help you scale your CPU and memory by adding new nodes to the cluster, and these can be on-demand nodes or spot instances, whereas Portworx Autopilot can help you expand your persistent volumes in real time based on a rule that you set as an admin. And you can also set another rule where you can automatically expand the amount of available storage capacity for your Amazon EKS cluster. So Portworx Autopilot works at a couple of levels. By automatically expanding your persistent volumes and automatically expanding your available storage capacity on the backend. For this demo, we have a simple cluster with two different node groups. First node group is specifically for running storage. So that's where Portworx is installed. Those nodes are behaving as storage nodes. They are participating in your cluster and providing storage for your stateful applications. The second node group is where we'll scale automatically using AWS Karpenter and provide you with additional compute and memory capacity as and when your applications need it. So you can have this architecture on your Amazon EKS cluster, or you can customize this even further based on the applications that you have running on Amazon EKS. But this is the architecture for this specific demonstration where we'll automatically scale storage using Portworx Autopilot and compute and memory using AWS Karpenter. So we'll start by demonstrating Portworx Autopilot first, and to do this we'll deploy a simple Postgres application in one of our namespaces and use a simple autopilot rule to monitor the utilization on our persistent volume and have Portworx automatically scale that persistent volume when those conditions are met or when those thresholds are exceeded. So let's go ahead and apply those YAML files to deploy our application. So first we'll deploy the persistent volumes that we need for Postgres. So this will be our PG data and PG state persistent volumes. And if I can type the command correctly, kubectl apply -f Postgres vol in PG1 namespace. And then once the persistent volumes are up and running, we'll go ahead and apply the app or the deployment object, which will deploy a Postgres pod for us, and that pod has a couple of containers. The first container is obviously the Postgres container, but we also have a second container called PG bench, which will be generating data against our Postgres database. So as you can see, our pod with two containers is now in the container creating state. And once this is up and running, we'll go ahead and look at the logs as well to validate that PG bench is actually generating some data and filling up our persistent volumes so that Portworx can automatically scale it as needed. For this demo, we have for the autopilot rule to work, there are a couple of different label selectors that we have specified in the rule as well, and which we'll look at in detail when we look at the actual rule. So let's go ahead and look at the logs first. So we'll just use kubectl logs -f, select the name of the Postgres pod in the PG1 namespace, and select PG bench as that specific container. So here you can see we have data being written to our persistent volume, and you can see that we have close to 2.7 megs to 2.7 gigs of data already being written. If we look at the autopilot rule that we have deployed in our system, as we said, we have a couple of namespace selectors and label selectors where we match whether the persistent volume has app equal to Postgres label set and type equal to DB label is set on our namespace. Only if these two parameters are met, that's when we'll go ahead and validate the conditions or check for conditions. The condition that we have set here is if the used capacity of a specific persistent volume exceeds 50% capacity. So if it goes more than or greater than 50%, that's when Portworx will perform the action that we have specified in this YAML file as well. So we specify the condition, and then action is scale percentage, which is 100. So that means basically whenever we meet that condition, Portworx will double the capacity of our persistent volume. So we start this exercise by deploying a 10 gig Postgres volume, and when we hit that threshold, it will expand it to 20 gigs. And then you can also set a max size on the persistent volume. So 200 gigs, even if the condition is met, but the capacity is already 200 or more for the persistent volume, don't perform any action. And this is again fully customizable by your administrator. Once this rule is already in place, you can monitor the events and see that your rules, when you first deploy it, go into the initializing phase. Then they go from initializing to normal, and as soon as that condition is triggered, it goes from normal to triggered. And this is where we know that pgbench has written more than 50%, so more than 5 gigs of data against our persistent volume, and Portworx needs to expand the capacity. So once the rule is triggered, it goes into the active actions pending phase, and then from active actions pending, it goes active actions in progress. What does this mean? This means that Portworx is expanding our persistent volume in real time and expanding the amount of capacity that our application has to use. This helps administrators because they don't have to monitor storage utilization on individual persistent volumes in real time. They can just set these autopilot rules against all of their applications and customize it for individual applications and individual namespaces. And once all of that is done, Portworx will handle all of the backend tasks of expanding your persistent volumes automatically to ensure that your applications always have the storage that they need and never go offline because they ran out of storage. So that's how easy it is to use Portworx Autopilot with Amazon EKS to monitor and automatically expand the amount of storage that you have available for your stateful applications. So as you can see, we have a 20 gig persistent volume, which originally started in the YAML file as a 10 gig persistent volume. Just to highlight that we did expand the volume in real time. So that's it for the storage automation capabilities of this demo. So we showed you how easy it is to expand storage. In the second part of the demo, we'll talk about how you can use AWS Karpenter to add more nodes automatically to your Amazon EKS cluster when your applications need more compute, CPU and memory storage capacity. So for that, we'll use the demo application that AWS has available for us to test out AWS Karpenter. It's a simple deployment object called inflate, where each pod basically needs a CPU to run. So what we'll do is we'll go ahead and apply this YAML file against our Amazon EKS cluster. And as you can see, the replica count right now is set to 0. So when the deployment object comes online, it won't have any active replicas. So there won't be any pods in our default namespace. To demonstrate the scale out operation, we'll go ahead and increase the number of replicas for that specific deployment object and monitor how new nodes are being added to the cluster. So here, as you can see, we have 4 nodes in our system that have all been created at the same time, running version 1.21 when the cluster was originally created. Now, if we scale our deployment inflate to 20 replicas, this is where it knows, or the Karpenter object or custom resource knows that, okay, you need more capacity in your cluster to support all of these 20 replicas. And that's when it will get more capacity for you and automatically add a new node into your Amazon EKS cluster. To see the thing in the expansion in progress, let's go ahead and execute or use a watch command on kubectl get node. So let's just use our second terminal session, do kubectl get nodes -w, and you can see that a new node has already shown up in the last 30 seconds. So it went from unknown state to not ready, and then just in a few seconds or a couple of minutes, it will go from not ready to ready and participating in the cluster and running those replicas that don't have a place or resources available before the scale out operation happened. So once the node is ready, Karpenter will make sure that all the replicas now have nodes that have enough resources on them to run their application. Another thing that you can do using Karpenter is set TTY, or time to live, where if you scale down the application, scale down the number of replicas, it will automatically remove the nodes that are added as well. So you can scale out and scale back whenever you want, whenever you need more capacity or when you don't need that additional capacity. So that's how easy it is to use AWS Karpenter. So basically we use AWS Karpenter for compute and memory, and for you use Portworx Autopilot for storage, and both of these work in cohesion to ensure that your containerized applications or your stateful applications always have the resources that they need to run successfully on Amazon EKS. So that's it for this demo. Thank you for watching.